and we'll get. All right. Thanks everyone for joining us. Like I said, hopefully everybody is staying warm and not too much inconvenience from the ice and snowstorm we had. Um, this morning, we're going to talk about skimmer basin design for construction and post-construction. We try to focus on different states each month. We do this. This month, we're going to look at Virginia and Indiana. Those teach you when you signed up and you answer some questions for us, kind of helps me gauge, who is going to be on here. So we try to focus on, whoever we have the most attendees from. And we have a
Yeah,
lot
I've
from.
got the background. I've got a webinar starting. I was trying to keep it from interfering with y'all.
If you can, if you can mute,
Just
just
No, I haven't. Yeah, I haven't gotten
thank you. Those that were on there, if you will. I'm gonna put everybody on mute just to keep the background noise down some. So, all right. So, a little quick about me. My name's Jamie McCutchen. I'm the principal founder of Rymar Waterworks. I am a 1992 grad of Clemson University in civil engineering. I founded CCAD Engineering, which is a small civil site work firm, back in 1999. I sold it in 2018. Invented the Marlee float skimmer in 2013, and I am a licensed professional engineer in South Carolina, North Carolina, and Georgia. I say all that just to give you a background. This is intended to be a technical session to hopefully you will learn some things today that you can put to work, and that's the point of what we're doing here. So I'm also going to go ahead and stop my video now, just it helps with the recording. We are recording this, and it will be available on our website later today or tomorrow.
Good morning.
So today's agenda, we're going to do introduction to skimmers and floating outlets. Just kind of talk about why we use skimmers. We're going to talk about the basics of skimmer basin design for construction. We're going to focus on a couple of important items that are critical design criteria. Then we're going to take a little pivot. We're going to talk about permanent use of skimmers for post-construction, both the benefits and challenges of that. One of the key challenges is frozen conditions, which a lot of the country is experiencing right now. Hopefully that is relatively short-lived for most of us. And then we'll wrap up, introduce the Rymar water quality filter, and talk about filtration design versus settlement or first flush design. So getting started here, got a little quick question, just to gauge the audience. How familiar are you with skimmers? So you should have a pop-up there to be able to answer that. If you can kind of let me know, it kind of helps gauge, who's on with us today. All right, looks like everybody answered that. We have just a couple that are new. Most are at least somewhat familiar and here to learn more. Appreciate that. And then a few that are very familiar. Hopefully we can find something productive for you as well. So in the past, what we did without a skimmer is we used some sort of perforated riser, typically had an outlet at the bottom of the pond, and we're discharging from where that sediment concentration is highest. The whole idea of sediment basins is get sediment to settle so it doesn't go out. But if you're pulling from the bottom of the pond, that's where that sediment concentration is highest. Skimmers have been around now for probably about 25 years. They definitely are newer in some parts of the country than others. The idea is pretty simple. Just have a device that floats on the surface and takes in water from the surface, or in our case, just below the surface. They're typically gravity flow devices. Most of them have some kind of vent tube to prevent it from siphoning, and they drain the pond from the top down. This lets the cleaner water that's near the surface of the pond discharge first and gives more time for sediment to settle to the bottom of the pond. There are a number of skimmers out on the market. The Faircloth skimmer was probably the first one that was commercially available. It's been around about 25 years now. Pretty much similar design to what it was before. Erosion supply is similar to Faircloth. You've got the IES, which is more of a T, kind of simple shape design, and then you got the Marlee float, which looks a little different than the others. This is a little quick video. So this is construction site. It's about 7 or 8 acres disturbed area in Anderson, South Carolina. I saw the basin there. That's the outfall, just the skimmer outflow. The water there's relatively clean compared to what was in the basin. So it's just a good example firsthand of how well skimmers do function just by simply releasing that water from the surface. This site was about 100 yards from Lake Hartwell, and so we were very concerned about turning the lake red or brown. And fortunately, the skimmer was doing a good job. We didn't have that issue. So, just a quick comparison, with skimmers, without, why do we use these? So, water withdrawal, like we said, you've got, without a skimmer, you got it from the bottom. So that's where the sediment load is highest. With the skimmer, you've got the surface, and that's the cleanest water. Again, that picture is a good idea. It's not necessarily clean water, but it's cleaner than what's at the bottom. So sediment retention, if it's at the bottom, there's a high chance of sediment resuspension and the sediment being discharged on subsequent storms. Whereas with skimmers, it's better, excellent sediment retention. Typically, basins properly designed with a skimmer easily achieve 90 to 95% TSS retention. Output quality, you're going to have much higher turbidity if you're releasing from the bottom of the pond, clearer water if you're releasing from the surface, like we saw in the video. Maintenance, much harder to keep things, clog free when it's at the bottom of the pond, much less frequent clogging when you're pulling from the surface. And the cost efficiency, typically you can reduce your basin size some. If you're going to do the bottom size, you're going to have typically a larger basin to be able to get that same trapping efficiency. So there are three fundamentals of sediment basin design. Basin number one is simply basin volume. So the basin volume is based on the area flowing to the basin. Now, regulations do differ as to whether it's total area or disturbed area. Most places it's total area. And then the other big difference is what is that volume per acre? So 1,800 or 3,600 cubic feet per acre seem to be the most common standards we see out there. However, it does vary. We are talking about Indiana today, and Indiana has a requirement of 5,600 cubic feet per acre. One thing we're going to stress today is use the required volume, not the actual volume to size that skimmer. And we'll go over that shortly. Number two is simply dewatering time. So again, sediment basins work by allowing time for sediment to settle to the bottom. The most common standard we see is 2 to 5 days. However, that also does vary state to state. So it's important to recognize the requirement within the state that you're working in. One common thing we see, and we see plans from all over the country. We see engineers that maybe work in one state, and that state standard may be 2 to 5 days, but then they go to another state, and that state standards may be different. Maybe it's 1 to 3 days, and so typically there's some overlap, but it's important to make sure you're meeting that regulation, whatever state you're in. And then flow rate, simple to determine once you know that volume. Dewatering is simply the basin volume divided by the dewatering times. Going to give you that flow rate. We do recommend looking at a range of flow rates, based on that allowable dewatering time. So this is a quick example for why it's important to focus on the provided storage required storage versus provided. So this was a pond. I believe the site was in Georgia. They specified 72 hours to drain. They specified an 8-inch skimmer. They did specify a Marlee or other approved, which we appreciate. The storage required was 1,754 cubic yards. That would have actually needed a 3-inch skimmer with a 2.5-inch orifice to drain that 1,754 in 72 hours. Would have been about $1,100 retail item. Sediment storage provided was 7,500 cubic yards, or just under that. Most likely this was going to be a detention pond, multi-purpose basin. It would be a permanent pond later. That pond would need an 8-inch skimmer with a 6.5-inch orifice. See, the cost of that 8-inch skimmer is much higher, only about $4,800 more than the 3-inch skimmer. But the critical thing here is that 8-inch skimmer would drain that required volume in less than 9 hours. So if you have a minimum time frame of 24 or 48 hours, which is pretty typical, you're now not compliant because you drain that required volume too fast. So that's one of the key things to stay compliant in doing that. One more quick question here, help me out, is where are you located? Most of you included that when you signed up, so I appreciate that. don't always know who signed up versus who attended. So looks like we got a lot from South Carolina, Ohio, a few from Indiana, and others. So I'm gonna end that poll and share those results. If we didn't include your state as a choice, feel free to put it in the chat. Just like to know kind of where people are from today. It really helps me gear these presentations to fit your needs. So stop sharing that and move to the next. Okay, like I said, we're going to focus on two states today. We're going to look at Virginia and Indiana. I know we have at least a couple of people from each state. So in Virginia, Virginia has just recently started enforcing requirements for skimmers. Virginia has their sediment basin standard is that you have 3,600 cubic feet per acre. Half of that, it's 1,809 cubic feet per acre, is in your dry storage, which is drained by the outlet. And then you've got another 67 cubic yards or 1,800 cubic feet of wet storage or permanent pool that is not drained. So when you're sizing the skimmer, you want to base it on that dry storage only. Do not include the wet storage. Again, in the text, you've got that same thing. Again, just confirm the dry storage, the wet storage, and they want it, the sediment cleaned out when half of your wet storage is full. They want you to design the pond for the principal spillway in a separate emergency spillway. And the principal spillway is to pass at least the peak flow from the 2-year storm. Now, the principal spillway is typically going to be the skimmer and the riser structure, assuming you have a riser structure. If it's like a temporary basin and you don't have a riser, you just got a pipe through, you'd want the skimmer to handle that 2-year storm and the emergency spillway to handle up to the 25-year storm. The other thing is they now do have dewatering for the surface for greater trapping efficiency. Common method uses skimmer, and skimmer should be sized to dewater the basin in 2 to 5 days. Up here they say sediment basins must not dewater in less than 24 hours or take longer than 120. Then down here they say for skimmers is 2 to 5. So where we see this enforced is that 2 to 5 day time frame. So now in Indiana, similar to there, you've got a dewatering zone volume. Said in Indiana, it's 5,600 cubic feet per acre, or you can calculate the 1-year, 24-hour storm. I'm not as familiar with Indiana storm events, but my guess is that 1-year, 24-hour storm is probably less volume than the 5,600 cubic feet. So if you're trying to minimize the size of your pond, it's probably worthwhile going through that calculation. And then in addition, Indiana requires 1,000 cubic feet per disturbed acre for sediment storage. So you don't include that in your skimmer sizing. You just include the 5,600 cubic feet per acre. Again, that's in the text as well, 5,600 cubic feet, or you can calculate it. Dewatering time, Indiana is 48 to 72 hours, so a much smaller range of time, only 24-hour range there for that. And then you've got a dewatering device. Wants to discharge from the surface using what they call them floating outlets. They do recognize that in Indiana, you're going to have some times for freezing. So you need to have alternatives for freezing time periods, such as a perforated pipe with a valve on it so that you can open that valve if the skimmer's frozen. And also, again, we talked about the 1,000 cubic feet per acre disturbed per acre for disturbed area for that sediment storage. And you should not include that in the dewatering storage volume. They have a temporary basin design data sheet, all the same information here. Just kind of run through that quickly. One thing, again, we recommend is establish the range of time. So when you're doing your data sheet, put in that 48 to 72 hours. That will allow you a range of flow rates. And we'll talk about that here as well, why that's important. Then they have some specific information for sediment traps and basins. Again, floating outlets are to be used, except they're unlikely to be used from November to March. So just have that alternative, typically some perforated riser with a valve on it that can be opened if needed. Again, discharge capacity, dewatering zone volume divided by dewatering time to give you that flow rate of the skimmer. So there's a little quick chart here. We're not spending a lot of time on that, but this just kind of compares different states. So we have Tennessee, Indiana, Texas, Ohio, and Virginia on here. Several of these states require a dry and wet storage. So Tennessee and Virginia have very similar requirements. Indiana and Ohio both have a dry storage plus 1,000 cubic feet for sediment storage. And Texas just has the 3,600 cubic feet or 2-year 24-hour storm. From surface area, the idea is you want a basin that spreads it out. You don't want a narrow, deep basin. You want a wide, shallow basin. So you have surface area formulas, or you have minimum or maximum depths. Maximum depth or preferred depth, or length to width ratios that are going to try to encourage that wider, shallower basin to give more surface area. Principal spillways, you'll see the 2 or 10-year storm typically. Emergency spillways, 10-year, 25-year storm. Some states 100-year. Where are skimmers required? It does vary. A lot of states say 10 acres or more, or maybe 5 acres if prepared. Some say any sediment basin, and then some are just preferred. Where we see this enforced is if you have an outlet structure, they probably want to see a skimmer. If it's a sediment trap, and a lot of areas you can use a sediment trap if it's maybe less than 5 acres or less than 3 acres going to the basin, and it's got the rock outlet, then obviously you wouldn't see the skimmer there. And then dewatering time, again, it varies. These states 1 to 3 days, 2 to 3 days, 1.5 to 3 days. Ohio goes 2 to 7, Virginia goes 2 to 5. These shorter time periods are a little less common. That 2 to 5 is what we see more common across the country. Now, here's one thing that you may not recognize if you haven't been on with us before, is skimmers are considered constant head, constant flow devices, and they're not. Testing has shown that skimmers do have a flow curve to them. And also it's important to understand that same size skimmers by different manufacturers can have significantly different flow rates. So this is a chart that was done by TRI Environmental. They did some work for the state of Georgia when they were redoing their erosion control manual several years ago. But they tested 3 different skimmers. You got type 2, type 1, type 3. We're going to look here at there's 3 columns on the right. The test tank was 4 feet deep, so it goes from 0 to 4 feet. 2 of the skimmers had very similar flow rates at 1 foot, so right at 37, and this is in gallons per minute or GPM. One skimmer was about double that at 70 GPM. All 3 skimmers that were tested had about a 25% increase in flow as they went from 1 foot to 4 foot of depth. And again, 2 were close, right around 50 GPM, and the third was nearly double at 90 GPM. So the main thing to understand here is if you are a consulting engineer and you just spec a generic skimmer and say 3-inch skimmer, you may not get what you want. You may have intended to have a slower flow and get the faster, or vice versa. So it's really important on your plans to identify that volume and drain time and flow rate, so that if a contractor does want to do some sort of an equal, if that's allowable, they have the basis, to determine what that flow rate should be and what skimmer it should be. So the skimmer design formula, this is pretty basic. I'll just do a quick example. So step 1, you're going to calculate that required basin volume. Again, that does vary by state, but let's say you had a 5-acre site, you're in an area with 1,800 cubic feet per acre, so that'd be 9,000 cubic feet required in your basin. Number 2 is determine that dewatering time. Again, the standards 2 to 5 days, or typical is 2 to 5 days. Check those local regulations. So several states we're looking at are not that. They're different than 2 to 5 days. Number 3, calculate that required flow rate. Again, it's just basin volume divided by dewatering time. That's going to give you a range typically. So if it was 2 to 5 days, that flow rate could range from 4,500 cubic feet per day to 1,900 cubic feet per day. And then you're going to select that skimmer size. So you can match the calculated flow to the Marlee flow rates or other skimmer, or we have a simple design aid that gets a little bit more detail for you. So our design aid is a spreadsheet. You fill in your project and company name information here, sediment basin name. We have a check up here to determine that, confirm the area to the basin and that required volume. So you're going to fill in the area to the basin and what that required is and get that required dewatering. Now, next step, you're going to confirm that range of drain time. So you're going to fill in that range here in hours. Then you're going to fill in your pond information. So pond depth, top length and width, bottom length and width. Now, important to understand the pond depth is just the depth to achieve the required volume. Your pond's probably deeper than 3 feet, maybe 5, 6, 8 feet deep. But if you achieve the required volume at 3 feet, you're going to use that. And then finally, you want to check and make sure that calculated pond volume and the required volume are very close to each other. We recommend with get about 5%, but this is a quick check to make sure that you based it on the required volume, not your total volume. Now what you're going to do after that is there's a skimmer report page tab at the bottom of the sheet. You click on that, it'll take you to the next page. It'll create a nice, neat 8.5 by 11. You can include this in your SWIP, or we've seen it on plans. The top of the page has that check here very clearly. It's got all your company information, all your input information, your minimum flow rate for the max time, maximum flow rate for the minimum time. So you may want to include that so you know that flow rate range you've now established. And because it is our tool, it's going to tell you which one of our skimmers with each orifice configuration meets that required range of time. And then you're going to select whichever one you as engineer prefer. In this case, I would probably shoot for our 2-inch with a 2-inch orifice, 69 hours. So 3 days is, that most engineers are selecting a skimmer that drains within 2 to 3 days. So that's a good choice. And it's going to be the least expensive for your client, contractor, and it's going to hit that, right around that 3-day mark. We also have some sediment basin details on our website. We'll go over that at the end here. But biggest thing is, again, make sure that you specify the required dewatering volume and drawdown time in your plan set. On the standard details, we have your sediment basin design criteria here. So this is going to apply to each basin on your site. Right here is where you set your min and max dewatering time. Down here we have a data block that has information for each basin. So it's got your drainage area, volume, surface area, pipe outlet information, spillway. You get over here and you put in your skimmer size, your skimmer orifice diameter, the skimmer manufacturer or brand. Is an equal allowed, yes or no? Most of the time that's yes. We recognize, we want to be fair to contractors, give them choices, and then specify that min and max flow rate. So when they do pick an equal, they make sure they meet that. By doing this on the front end, your review includes that range. And obviously sediment basins and skimmers are one of the first things to go into a project. So once they start, the contractor calls up and says, hey, I've got this skimmer left over from this other job. Can I use it? Well, does it meet that flow rate range? If so, simple shop drawing to confirm. Otherwise you'd have to go back through a review, and you probably don't have time for that since that skimmer needs to go in early. So this is our standard detail. A couple of quick things about it. All of our standard details include the flow rate information for the skimmer and each orifice configuration for that skimmer on the detail. We use this, what's called an orifice plate. We've got a video here at the end that's going to show you more about how that works. The most common question we get is this pipe length. How long should this pipe be? Ideally, you want the skimmer floating at about a 45-degree angle when it gets to the top of your riser. So that means about 1.4 to 1.5 times the height of your riser. Now, we do recommend a minimum of, say, 8 feet. You could go down to 6 if you wanted, if it's a small basin. Sometimes you have a really shallow basin, maybe it's only 2 feet deep, or the riser is only 2 feet. You want more than about a 3-foot stick of pipe there. It just functions better to have a little more distance from the riser for the skimmer. We also, if it's a dry basin, we call out for this 12-inch depression here, and that is so that the skimmer sits as low as it can and drains the pond fully. Otherwise, if you didn't have that and you graded your basin and then set a rock pad, your skimmer is going to sit up 6 to 8 inches, and so you're going to hold water in there that you may not prefer to do, especially if you're trying to get grass to grow in a dry basin. One of the new things we did last year is we developed this Marlee float skimmer calculator. So you put in your basin name, your required pond volume. So you just enter that. Typically you know what that is. Plug in your min and max time to drain. Now it's important here to put in a range of time. If you put 2 and 2 or 3 and 3, you're only going to get a result if it's exactly that. So put in a range. We recommend at least 24-hour range of time, and then you'll see each skimmer with orifice configuration that meets that range. Now you can then go click on the one that you want. If you want the smallest one, if you want to drain fastest within the time, whatever it may be, click on the download button. It's going to generate a PDF or PNG file for you It's going to have the chart up top with all the required information, and then our standard skimmer detail information. This is more of a generic detail, so it won't have the flow rate information. It'll just have this chart information to give you the right info for that specific basin. So engineers have found that very easy to use, very practical. So we hope you find that helpful. That kind of wraps up the portion to talk about construction. I'll check the chat real quick here. Just had a few people enter states, no other questions. So if you do have anything, let me know. Otherwise, we'll jump into the next section here. All right, so now we're going to talk about.
The question is about the skimmers. Can they be always below the surface of the water so that there's no freeze issue with them?
So it varies by skimmer brand. Most other skimmers than ours, the inlet sits right at the surface. So they're a little more susceptible to freezing. The Marlee float, the intake is about 4 to 8 inches below the surface. So you'd have to get, several inches of ice depending on which size skimmer. And they also have weep holes at the very bottom of the pipe. I'll show you that a little later. So it's still going to trickle in. It's not going to get the full flow if it's just using that. But if you're in Minnesota, if you're in northern Ohio, northern Indiana, those areas that may get a foot or more of ice, it's going to freeze, just about any skimmer. So
I'm in Georgia. We had a deep freeze over the last 3 days.
yeah, I'm in South Carolina. I think I would say in South Carolina, Georgia, maybe Tennessee, you probably didn't have more than an inch or two of ice. The skimmers that are directly on the surface, they're probably not working as well. But the skimmers that take in below are gonna probably still continue to work. I did get a couple of questions here before we jump in. I tell you what, I'm gonna launch the poll and I'll answer this question. So next one is, have you ever considered using a skimmer permanently? So while you answer that, got a question about when should an additional filter ring be added to the standard skimmer ring, and how durable is Marlee flow fabric? So typically we don't see that stone ring needed when you've got a skimmer, because again, you're dewatering from the surface and the skimmer is doing the majority of that. The filter fabric, it comes standard on the skimmer. It's intended to last 3-4 years, somewhere in that range. If you need it to be replaced, it's very simple to do that, but it's not as durable as the skimmer itself, which is a 20+ year product. So, all right, so we'll end poll. So majority of people said have never considered using a skimmer permanently, which is typical. We've got 9 that have considered it, and we got 2 yeses, which is awesome. Love hearing that we have people that have actually done it. So we'll kind of go through here and tell you why you might want, if you haven't done it, why you might want to consider it. So the first thing we'll do is we're going to focus on dry detention basins. Now we know there's wet basins, there's extended detention, there's wetlands, there's all kind of things, but the dry detention basin is probably the most common BMP for use in most areas. So you've got a dry basin, water comes in, and you got some sort of outlet, at the bottom of the outlet structure at the end of the pond. And sediment's going to accumulate there the highest. And so, again, if you looked at a storm event or looked at a typical basin, the skimmer is going to get removed. When you convert that basin from construction to post-construction, you're going to install some sort of low flow orifice at the bottom to release that first flush, is the common term. And you're going to do something to try to keep it from clogging, some sort of guard or filter to do that. And we've seen all kind of things. You can have grates, you can have like inverted outlets, you can have a perforated pipe that's letting stuff in. But if you were to look at the inflow from a storm, if the inlet is here on the left side of this bottom picture, you can have that suspended sediment, high sediment load coming in. As it goes from the inlet to the outlet, you're going to see the sediment start to settle to the bottom of the basin, and you're going to start to see cleaner water at the surface. So if we could release that cleaner water, that would obviously be enhancement for water quality. And with the sediment settling to the bottom, that's going to require more maintenance to keep that bottom inlet clean and flowing correctly. So skimmers, basins rely upon natural settling with sediment particles. That's pretty standard. We've established skimmers release that cleaner water from the surface. They have become the standard in most states for construction, And so if it's such a standard during construction, why would we not consider using that same method for post-construction water quality if they've been proven to be so effective? So a little quick case study here. So believe it or not, this is a pond. This was a former car dealership in Simpsonville, South Carolina. Not shockingly, they got a notice of violation for failure to maintain the pond. Obviously, it was severely overgrown and the outlet structure was not functioning properly. We went and did timbering, had 6 and 8 inch trees removed from this pond. You can still see some of them were left around the edges of the pond. But it had an enormous amount of debris in the pond and it would never drain. And we couldn't figure out what was going on. You could see the orifices here on the top left picture, but there was no orifice below that to drain the pond out. Finished cleaning up the pond, and what we found was there's a 2-inch orifice 6 feet below what is now the bottom of the pond. This pond's about 3/4 of an acre. It has 1.5 to 1 side slopes. You see very steep banks on this thing. So just getting down to a road in to be able to remove and take that sediment out was going to be very difficult, very expensive to remove it. So, and we were, after we learned of this, Greenville County, it was in, wanted that 2-inch low flow discharge rate to be maintained. So we went and worked with the owner. We said, hey, we think we can redesign this pond. So we did. We redesigned it and we retrofit it and we put in a 5-inch skimmer to replace the 2-inch low flow orifice to hopefully help with the maintenance issues. Now, initially the county refused to approve this. Skimmers had not, this was back in 2013, 2014. Skimmers were fairly new in South Carolina and they had not been used permanently. So in order to get approval, we had to agree to do this as a pilot program. So we were required to monitor the site monthly. So these are photos from monitoring to show that it was working properly. So about a year later, the owner was maintaining the pond. Landscapers went and cut all the vegetation on the sides, let it all fall to the bottom, and had a big rain, big summer thunderstorm, dumped about 5 inches of rain, just a few hours, washed all that debris down here to the bottom. You can imagine if that was a 2-inch outlet down there, there's no chance it was not going to clog up with that much debris. However, with the skimmer in there, it was able to function. They were able to go in and clean it out. This picture on the right, you can see that's about 8 feet. These are 6-foot riser sections. So that's probably close to 8 feet of height between those orifices and the 2-inch, what would have been the 2-inch. And if that had clogged, it would have been extremely difficult and dangerous to get to it, to get it unclogged. So if you're going to use skimmers post-construction, we got to know how to put those into our model, right? And so now that Civil 3D has HydroFlow built into it, that seems to be the most common hydrology software. So first thing you're going to do, and I will say we've got a deeper dive in this on our website, but we're just going to do a quick highlight today. So first thing you're going to do is build your basin. So when you build your basin, you want to build a stage to be able to enter in your skimmer flow. So we've got a 0, 0.1, 0.3, 0.5, and every 1/2 foot up to 4 feet. This basin just happens to be 4 feet deep. Again, our skimmers include, our skimmer details include the flow rate for that 0.1, 0.3, 0.5, and then 1/2 foot up to 4 feet deep. All this is based on third-party testing. So now you're going to go in, you're going to build your outlet pipe. So in this case, we have an 18-inch pipe going out. This is a area, it's a city of Greenville, South Carolina. They require quantity control during construction. So we've got a 6-inch orifice in the outlet structure, about just under 2 feet from the bottom. We've got a riser structure that's about 3.6 feet tall. We have a rectangular weir in the top foot of the riser structure. And then to model the skimmer, this kind of the secret sauce here is this user-defined column. So you would just plug in the flow rates off the detail at that stage to build in the flow rate curve for the skimmer to accurately model it in HydroFlow. Now, what will happen, often we're going to have ponds over 4 feet deep, and the test tank, unfortunately, was only 4 feet deep. So what happens if it's over 4 feet? Well, you got a couple of options. You can, if it's say 4.5, 5 feet deep, you can just maintain that flow at 4 feet. If it's deeper than that, you can extrapolate it based on the last data points. Or let's say it's 8 feet deep or more, and you want to get more accurate, you go back to our design tool that we talked about earlier, put in a pond depth of 8 feet. This is going to break that 8 feet into 20 different increments, and it's going to calculate the flow rate at each increment. And so it'll give you here, and then you can plug that into your model. You see, this is our 6-inch skimmer with a 6-inch orifice, fairly, a little bit of change across that. At a 4-foot depth, we got about a 0.78 CFS flow rate. At an 8-foot depth, we're up at 0.86. Now, not a huge difference, just 0.08 CFS difference in flow rate. But as you engineers know, when we're trying to do our pre and post calculations, and we're trying to get it to the, show we're maintaining the post just under that pre, a tenth of a CFS or something can actually matter. So this is the most accurate way to build in that flow rate curve. When you do that in HydroFlow, if you look at your schematic, you're not going to see your normal low flow orifice here. There's our 6-inch orifice, our rectangular weir and riser structure. But if you look at your stage discharge hydrograph, then you've got flow here. That's your skimmer flow, and then your other orifices kick in. So the skimmer is working there and built into your model. If there's any questions on that, we do have about a 15-minute step-by-step tutorial on our website that'll walk you through HydroFlow. Also, if you use HydroCAD, it's a little bit different, a little easier. The Marlee float is built into HydroCAD as a user-defined or special purpose outlet, and so you can plug it into HydroCAD a little bit easier. So, all right, we're going to wrap up here, talk about filtration-based water quality. So this is probably the biggest new thing we have. I'm sure we have some regulatory MS4 folks on with us today. Love to hear some feedback from you on this as we go through, and whether you would, like it, don't like it, would allow it, not allow it, in your area. So we've developed a filter that goes around the skimmer. So it's 2 stages. It's got an outer layer that's just basically debris, large particle removal. It's a woven polyethylene fabric. It's a Mirror 5402. That's what we've been using. We have an inner layer that is a non-woven fabric. It's made by a company called Adsorbit, or it's called Adsorbit is the material. It will help with TSS. It also absorbs hydrocarbons. It has some testing that will help on metals. And we're looking in to see if it'll help with nutrients. The idea is that the skimmer pulls water through these filters to get to the skimmer and then gets discharged. The filters hang 2 to 3 feet deep in the basin, and that depends on the size of the skimmer. So 4-inch and smaller, it hangs 2 feet deep. Our 6-inch and larger goes 3 feet deep. There's not enough turbulent force to pull those sediment particles back up that 2 or 3 feet to get discharged. So we let gravity do the job. Below that 2 or 3 feet, we let the filters do the job to clean out the surface water. So we developed this over really 5 years or so. So this was our prototype. This was about our 6th or 7th prototype that we developed. So this goes back to that same pond that you saw earlier that had the NOV that we put the skimmer in. So we've updated the skimmer, put the filter in around it. First one was just a turbidity curtain, but it did have fabric in to allow flow through. And then here's the inner fabric. One thing about the inner fabric we found was we really weren't getting the flow through that fabric. Although this fabric's rated to have like 125 gallon per minute per square foot flow rate, when the fabric's just hanging vertically and the skimmer's trying to pull water through it, it wasn't really getting enough force to pull it through. So what we did is we went back and we created this with 2 layers. So there's 6-inch slits, and we offset the 2 layers about 3 inches. So we create kind of a weaving motion through the fabric, which generates contact time. So this fabric I'll describe it as sticky. And so as water comes through there, it tends to grab the sediment particles, other pollutants in the water, and hold on to them to keep them from being discharged. So it's kind of a polisher once the water comes through the outer filter. One interesting thing that happened during our prototyping is vegetation started to grow in the non-woven. Like I said, it's sticky, it grabs those seed particles. And we're going to look in the future at maybe putting some vegetation in there on purpose for nutrient removal. Now it's a small area, so I'm not sure how much impact we'll have in that small area. Maybe we'll partner with some floating wetland people and put it around the skimmer to have more nutrient removal. So again, we monitor this for about 2 years. Just field observation. I won't say we did any testing, we didn't take samples, but you could see less turbidity and you see minimal sediment. So this is actually the outfall from the basin. Pretty clean water compared to what's in it. In this picture on the left, you can see turbidity on the outside of the filter is higher than on the inside. So just visually, it looked like it was doing a good job. So we decided to have it tested. So we went to TRI and had them do testing for us. And they confirmed over 90% TS removal for this skimmer filter system, in a basin. So it's important to understand the testing. You may or may not know, ASTM now has testing for stormwater products. The specific method is C1746. And so that's a standard test method for sediment retention devices. The tank was set up to minimize a dry pond. And then one other thing we did that was important to understand, when you have a pond, you typically have multiple things that are helping that pond, right? You've got a forebay, you've got vegetation, you've got travel distance, you've got a variety of things that are going to affect sediment removal. If we truly modeled a full dry pond, it would be very difficult to say how much one thing did versus the other. So what we did is we negated all those items, and the sediment-laden water was introduced to the tank about 1.5 or 2 feet from this outer filter. So it's coming straight in here and immediately going through the filter or under the filter, getting to the skimmer to get discharged. So basically no travel distance, no forebay, just see what this system by itself can do. Using this, we tested 2 different skimmers, 2 different flow rates. Both of them got over 90% TSS removal based on the ASTM standard. I will also mention we are in process right now negotiating with NJCAT. Many of you may be familiar with NJCAT. NJCAT has protocols for products. Those protocols were developed with a product in mind. None of those previous products were any kind of product that was really intended to be used in a pond. So we're having to spend quite a bit of time with NJCAT to establish how we're going to test this per their protocols, so that once we do that, they can certify that it does meet that. And so that is our intention. We're working very hard. I'd hope to have that done by this end of this month, but we're still going back and forth with them about exactly the fine point details of how we're going to test this so that they can verify the results. So now we've gone back to that same pond. It's kind of become our playground, and we've installed what we consider our commercial version. There, we've got a time-lapse camera set up, and we're keeping a close eye on it. So again, you've got the polyethylene fabric on the outside, it's orbit on the inside, skimmer. There, again, this is a dry pond, so it does drain out. One thing that's happened is beavers invaded the pond and built a dam, or kind of tried to dam up around the outlet structure. They did not stop the skimmer. You can see the filter's been worked on a little bit. It's still working pretty well. There's been a little bit of, I think the beaver's been chewing on a few things, but this time-lapse photo, you can see how the pond fills up. The skimmer filter combo drains it down slowly. I will say the skimmer is still sized based on simulating that 2-inch outlet flow. We haven't gone back and re-permitted the pond to allow a larger flow rate or higher flow rate out of that. We're still maintaining that while we're in this prototyping stage. But it took the beavers another 3 months. They finally got to the skimmer and packed some mud in it. We had to go out and maintain it, but we've done that. It's been working pretty well. So let's talk about what are some benefits to filtration versus settlement. So just not factoring in skimmers yet or surface flow, just for filtration. So the peak rate of discharge can be based on the filter treatment flow rate up to the first quantity storm event, which is going to reduce your pond size by 15% or more. So what we're saying there is that your traditional first flush method, it's intended to force ponding to allow settlement. And so you're going to take that first inch, 1.2, 1.5, depending on where you are in the country and what the requirements are. You're going to release that volume over, say, 24 hours. And that intention there is to that time and that volume will allow the sediment to settle and release that cleaner water. Okay. A couple of problems with that. Number one, what happens on a small storm event? You're not getting very much ponding, so you're not getting much treatment. Number two, that standard greatly increases the pond volume. If you can let the water out faster by treating it with a filter, say up to that first quantity event, which is maybe your 2-year storm, then it's going to reduce your pond size significantly. Again, the filter is going to treat 100% of the runoff from storms up to the peak rate of the filter. Like we just mentioned, when you use that first flush volume method, hadn't rained in a while, and you get a little, 1/4 inch rain over 3 or 4 hours, water is probably going into that pond or it's probably going out of the pond basically as fast as it's coming in. And so if your treatment system is based on ponding to allow settlement and you get no ponding, how much treatment are you getting? Whereas with the filter, everything's going through the filter regardless of how low the flow is or how the flow is up to whatever the filter can handle. And then finally, the filter media can be customized to target specific pollutants of concern. Some areas are looking at hydrocarbons, pretty common. Other areas are looking at metals. Other areas are looking at nutrients. There's a variety of products out there that can do a variety of things to help with those pollutants other than TSS. Some additional benefits are the pond provides a large containment volume. So now there's filtration products that are used in vaults or catch basins. They work. They require much more maintenance because they have a very limited volume that they can hold. This is a big one. We're working with several people on this. There's excellent potential to retrofit older basins that did not include water quality benefits if that peak flow rate can be maintained. So if you've got a pond and it was built 30 years ago or 40 years ago, and it was only looking at quantity control, or in some areas of the country, it may have been built 5 years ago and just looking at quantity control, and you go back and you do some redevelopment on that site. So you got a shopping center and you're going to take out a old Perkins restaurant, you're going to put in a Chick-fil-A. All right. Most MS4s are using that as a method for you to provide water quality, at least for the disturbed area. So how do you do that? You can go in and isolate that water. Maybe you put in some catch basin filters, other things. But if you can go to that pond, put in a filter system that can allow your peak flow rate for your 2-year storm to be maintained, now you can treat the entire site very cost effectively. And then filters and ponds can be relatively easy to access and maintain. Again, there's filters and other products that have vaults and systems that require confined space entry, specialty vac trucks, whatever, to kind of suck the stuff out and maintain it. If it's in a pond, you're not going to have to remove that sediment very often, typically at least 5, maybe 10 years. And you're going to be able to just walk out there and get to it, or pull it to the side if it's a wet pond, or worst case, take a little boat out there and get to it. But you don't have to do the confined space entry and the expense that comes along with that. So what are some benefits to using skimmers with filtration? So we go a step further. We could come right here in this pond, put in a perforated pipe, wrap it with a filter, or put some sort of filter pipe around it. But what's going to happen is that at the bottom of the pond is going to be where the sediment concentration builds up the fastest. It's going to take the most maintenance. By putting in a skimmer, now you can use the skimmer to control the peak rate for the storm events. So if you can design your skimmer to control your 2-year event, that's now your flow control, and that replaces that low flow orifice. The skimmer is going to increase the filter efficiency by withdrawing from the surface because the water is cleaner there. So you're not trying to treat this heavy sediment laden water at the bottom. You're trying to treat the cleaner water. So your filter is going to be more efficient, last longer. And then again, pretty easy to access. Just pull the skimmer over to the side to get to it so you can change or maintain the filters. Now, there are some challenges to using skimmers with filtration. Number one is they are going to be prone to clog over time and will require maintenance and periodic cleaning or changing. We're currently recommending changing the filter every 2 years. That's based on the original prototypes. Like you saw in the photos, we've got the commercial version out there. It's been there about 2 years now, so we'll kind of monitor it, see how long it lasts, how long it can do. But I feel like 2 years is a good time frame. The skimmer has got to be durable, last more than a few years, be suitable for permanent use. Like we looked at before, HDPE products are what you want to use here, not PVC. If you use a PVC skimmer, that skimmer is going to degrade due to UV over time, and it's going to have to be replaced much sooner as well. And then the biggest one for us, I didn't mention the freezing conditions. If you're in an area with significant freezing, this may not be the right product, right? You've got to evaluate that. If that's your water quality, is that going to work, or how often is it going to be frozen? And then the other one here, there are no established standards or basis of design for permitting based upon combination of pond and filtration. So if you're an engineer or if you're an MS4 and you've got anything in a manual that shows how to put a filter and a pond together, I'd love to see it. We find that's our challenge. And most places do have standards for mechanical treatment devices, proprietary products, that sort of thing, and you can apply those to this. But we're working on getting that NJCAD approval, so it'll be a little bit easier for approval by the MS4s. We talked about how this could reduce the volume. So we did a 5-acre site and kind of ran a traditional first flush method versus a filtration-based method. And we came up with about a 30% less pond volume required for the water quality event. So first flush method, that 5-acre site was having to release at about 0.25 CFS to release that inch over 24 hours. That required a storage volume about 0.245 acre feet. However, with the filtration method, our 2-year flow rate for the theoretical example was 0.75 CFS. And so we're letting that water quality out about 0.7 CFS, which is just below the 2-year storm. That only required a storage of 0.174. So about 0.07 acre feet less volume, which is about 30% less volume between those two storms. And the other benefit is, since the skimmer is your 2-year storm control, you're now treating all runoff up to that 2-year storm event, and you're also treating the trickles because they're going through the filter. All right, so now that you're aware, one last poll for you. Now that you're aware of skimmers or benefits for post-construction for use of skimmer, what are your thoughts? Would you consider it? Maybe, yes. Somebody's going to still say no, because I always have at least one. There we go. Okay, at least got 2 people that would say no, which is fine. You're the engineer of record, and it's up to you what you'd like to use. So in the poll here. All righty, and share the results. We did have 2 no's, should just be temporary. We fully respect that. A majority said maybe, for the right project, which we agree with. And 11 say yes, it's a good idea. So we hope that you'll consider it on your next project if you're open to do that. All right, and we'll wrap up here. We got a little less than 10 minutes to go. We're just going to do the short version of marketing for the webinar. So this is our website. Encourage you to visit that, rymarwaterworks.com. We work very hard to keep this up to date, make it very useful for everyone that goes there. Mention our resources and training. So this webinar, and I think we keep our last 5 or 6 on there, will be available on the website. We also have a YouTube channel that has all of our webinars. Again, we try to focus on different states each month. So if you're an engineer that, say, lives in Ohio and you got a job in Texas or Indiana or wherever else around the country, there's a good chance we've done a webinar on that. So go check us out. Maybe it'll provide some guidance on, at least on the skimmer basin requirements. And then we also have this training series, which is an 8-part series that kind of breaks down today's presentation. We have other things. We have like SEDCAD. So if you're in South Carolina or a state that uses SEDCAD for sedimentology, we have a SEDCAD training there. We have a HydroFlow, more deep dive, etc. So please use those. We have one download. We make it really simple. So we have our engineer spec pack. If you'll go to our website, it's a zip file. It's going to be organized for you. It's going to have 3 folders. So you're going to have folder 1 is your Marlee float skimmer details, design tool, test data, supporting information. This is everything you're going to need to include the Marlee float in your skimmer basin design for construction. We're going to have sediment basin details. Again, those are we have 4 different ones. We have wet and dry for both with the riser and without. These have been compiled from multiple states, intended to fit as much as we can. And then finally, you're going to have the water quality basin information, design guidance, test data, supporting information. We'll be adding our NJCAD approval to this as soon as we have it, but this is all the water quality post-construction you need. I will say, if you're on here today and you say, hey, I like that idea, reach out to me and let me know where you're considering using it. I will reach out to that specific MS4, make sure they're aware of it, make sure they'll allow it. Again, we have our third-party testing. It's to ASTM standards, so most places will allow it. There are some places that have standards or have a list. Most of those lists start with NJCAD approval or Washington tape approval, and so we'll be working on that as soon as we have it, but we don't quite have that yet. So just real quickly, why would you choose the Marlee float? Just kind of quick summary here. So number one is material. We're HDPE. Most other competitors are PVC. HDPE is highly UV resistant, extremely durable, 20+ year life. Whereas PVC, it's going to UV degrade, it's going to crack over time, just not going to hold up. Flow rate, we have 4 to 5 flow rates per model of our orifice plates that are easily adjustable. All rates are third-party verified. Others have more limited flexibility or more difficult to adjust, and they have very limited test verification of those flow rates. Maintenance, because of our design, we're less prone to clog. That debris guard and taking water from just below the surface is a big deal. Takes much less maintenance. The surface entry clogs more often. You get leaf litter, trash, debris floating. It's going to clog those skimmers up more often. Third-party testing, we're ASTM verified, and all of our flow rates are published. Not all competitors are tested, or the flow rates are published, or at least easy to find. I'm not saying they haven't done it, but I haven't been able to see that. Approvals, big deal here. Any DOT out there that has a QPL for skimmers, we have applied and been approved by that DOT. If you come across one that's not the case, let me know. We try to keep an eye on that. But some state DOTs may have added a QPL for skimmers we're not aware of. And we are accepted by all state agencies. We do not have any single state that has ever declined the Marlee float skimmer. Most states do not have an approved list. So if you go ask a state, is the Marlee float approved? You may get a generic answer. No, it's not, but that means we don't approve those. Other skimmers, some have similar approvals. They've been around for a while. Others may not. And then post-construction use, we have proven case studies. We've been working on this for 12 years now. Our pond in Simpsonville, we've got some other ponds in North Carolina that have been using it. 20+ year product life. Other competitors, I'd say there's just less evidence in the field, and PVC is simply not suitable because of the limited product life for use there. A little final video here. So we talked about our orifice plates. So this just shows you how simple they work. And this is sped up a little bit, so my guys don't work quite that fast. But see, just take that rubber plate out, place the skimmer back in. There's a small hole in the center, and there's a little metal nub there, you can see. Make sure that it is centered back in, and then it's really simple to close grate. We have these little clips to put it in. There's no tools required. Make it really easy for the inspector or contractor to get to it. We have 6 different skimmers. We have our 2-inch, which is our smallest, goes down to a 1/2-inch orifice. 250 cubic feet per day is a trickle, 0.003 CFS. Then we go all the way up to our 8-inch and our 8-inch with 8-inch pipe. We refer to this as our 8-inch max. Our standard 8-inch uses a 6-inch pipe to connect the skimmer to the outlet structure. 2, 3, 4, and 6 all use the same size pipe. So 2 uses a 2, 3, 3, etc. Then our 8-inch with the 8-inch pipe, again, our 8-inch max, it uses an 8-inch pipe to connect to the outlet, has a flow rate of 1.8 CFS. That's nearly double what most other 8-inch skimmers are. So I hope we've got some consultants on here today that do solar farms or, some big projects, some maybe automotive plants, those kind of things. We've seen as many as 5 8-inch skimmers in a basin specified before. If you got 2 of competitors 8-inch, there's a good chance you can use 1 of our 8-inch max to reduce that, make it much less expensive, much easier on the contractor. So, all right, and we hit dead on our time today. If there are any questions, we've got a minute or two. I'd be glad to stay on. If you need a PDH, please email us at info@rymarwaterworks.com. We'll get you a certificate right out. For those in Indiana, we are approved in Indiana to provide PDHs. If you're in a state that requires any kind of approval, please let us know. We haven't really found any others that do that. We've checked around a few, but we do feel like this is a very technical presentation. Certainly, hopefully you've learned something, and would appreciate any feedback. If you have any other questions, please feel free to unmute or add it in the chat.
Well, you mentioned in your presentation about the enforcement, which is the agency that enforces that, EPA or somebody else?
Well, enforcement is typically up to the local MS4, so either a state level or local city county level. And that has been a common theme is, engineers can design things great, but if it's not enforced, if maintenance is not enforced, they may not work well. So I think that's one thing to keep in mind is, makes sense to design things that are going to last if you can, and things that require less maintenance are always better. But again, there's not one product out there that I'm aware of that never needs maintenance, right? It's going to have to need some maintenance. And so that's a common theme. And I'm sure some MS4s are on here that agree that, it's not the easiest thing to do. So again, thank everyone. Hope everybody has survived the ice and snow, and hope you stay warm. Appreciate you joining today. And we'll have this presentation up on our website shortly.
Thank you.
Have a great day. Talk to you later. Bye-bye.